Hello Math20-2. Today we're doing our fourth lesson on quadratic equations, and in this lesson we're going to see the similarities of roots, zeros, and x-intercepts and what they are. They kind of all are the same values, and we're going to see why. So here's our first example. It says, find the zero of this equation. Okay, so find the zeros of that function. When we say find the zeros, that's just saying f of x is equal to 0 or y is equal to 0. We want to make the equation equal to 0, and what value of x makes the equation equal to 0. That's what it means by finding the zeros. What value of x makes the equation equal to 0. Okay, so let's put this in. So we want 0 is equal to 2x minus 6. Okay, continue this, and I'm going to end up getting plus 6 plus 6. 6 is equal to 2x. Now divide by 2, divide by 2, and I get x is equal to 3. And that is my 0. Now, let's take a look at this next one here. This next one says, we're just going to generally go over this. It wants to find the x-intercept, and I'm going to first do it using my graphing calculator. So I'm going to move this up so we can see everything nice and clear. So I'm going to use my graphing calculator. In my graphing calculator, I'm going to go y equals, and here I'm going to go 2x minus 6. And I'm going to graph. There's my graph. Now, if we remember, to calculate my x-intercept, I want to calculate the 0. So I can calculate the 0. There we go. And go over a bit. So we want left of the curve. That means we're on that side of the x-intercept. Well, if I look at this, this is that way of the left of the x-intercept. It is left of it, so I'm going to push enter. We want to point right on the curve or line of the x-intercept. There's right. And we want my little guess, which is right there. Enter. Oops. And that was 3 and 0. Okay, so we got 3, which is the exact same thing. Notice how when I did this, I would second calculate and the 0 to find my x-intercept. Because the reason why it's called the 0 and the x-intercept is the same thing, because if I look at this, what is my y value on the x-intercept or the x-axis? My y value is, well, there's no positive and no negative. It is 0, because anytime we go up a bit, all of a sudden it's positive. We go down any little bit, there's a negative. So my y value is 0. That is why the x-intercept is the same thing as the 0. Okay? And the root is when the equation is equal to 0. Same idea. All right? When we factor it and then we make them equal to 0, that's kind of like finding the roots. So that is how they are kind of related. So, there we go. If we look at investigation number 2, it's doing the same thing, except here we have a, just move this so we can see, here we have a quadratic, which is a parabola. Now, if we remember from before, for a quadratic equation or a parabola, we're going to have either 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. That's just what we're going to have. Now, if we have that many x-intercepts, that means we have 0, we could have 0 roots, 1 root, or 2 roots, or 0 zeros, 1 0, or 2 zeros. Okay? When we're finding them. And we'll go over and review this first. I'll let you do that by yourself. Now, here we go. So, as soon as we call it a function, so like where it's f of x, we're talking about the zeros. Okay? So the zeros of the function, and when we're looking at a graph, normally we want the x-intercepts. Okay? And then the next one, if we say y is equal to 0, when we're looking at the term y equals 0, that is talking about the roots. Okay? So when it's in f of x, that is the zeros. When it's in y, when we put a y equals 0, if we say f of x is equal to 0, we're talking about the zeros. If we're saying y equals 0, normally we're talking about the roots, and if it's on a graph, we're talking about the x-intercepts. Those are all the same things. So, there we go. The graph of the function has x-intercepts of, well, we look at this, -2 and 3. -2 and 3. And a y-intercept of -6. That's what's so nice about this. This also tells us our y-intercept, -6. It's always the constant, okay? Now, this equation factored is this. Normally we factor it to find the zeros. And to find the zeros, we make it equal to 0. Well, that's going to be -2 and 3, same as before, because we have to make this could be 0 or this could be 0. So we have two possible answers. So if this is 0, so x plus 2 is equal to 0, or x minus 3 is equal to 0. The next one is the equation has what roots? So this was probably a y equals equation. That's going to be -2 and 3. We would just factor it and solve again. Okay? So let's take a look at the next one. It says, consider the following function. Okay? So there's my function. Describe how the features on the graphing calculator are used to determine the zeros of the function. Okay? So let's take a look at this. We want to find the zeros of the function. So that's going to actually be my x-intercepts. So turn this on, y equals, and my equation is 2x squared, and then what do we have? Minus 7x and plus 3. And I'm going to graph it. There we go. There's my graph. Now, describe how the features of the graphing calculator can be used to determine the zeros of the function. Well, we want to find the x-intercepts. The x-intercepts are the zeros. Okay? So the x-intercepts are the zeros of the function. Okay? So the x-intercepts are the zeros of the function. And to do that, how are we going to do that? Well, state the zeros of the function. That's simple. I'm just going to move this up a bit. We just go into here. We're going to go calculate. Oops. Second, calculate. And we're going to calculate my 0. That's it. So we go left bound of the first one. There's my first one right there. Left. That looks left of that x-intercept. Push enter. Right of the x-intercept. That is right of the x-intercept. Because the x-intercept there. We're a little bit right. Enter. And a guess where my x-intercept is there. Enter. So I get 0.5 and 0. So I have x is equal to 1 over 2. And what is my other one? Well, let's try and find the other one. Second, calculate. We want the 0. So left of this intersect, I still want to be on the same curve. So right there, that's still left of that intersect. And then right, here's my intersect. That looks a bit right. Over, enter. And then my guess is there. I have 3. Okay, so 1/2 and 3. Those are my two zeros. X is equal to 1/2 and x is equal to 3. State the roots of this function. So we want it when this is equal to 0. Well, the roots, well, that's the x-intercept. They have to be the same thing. Why? Because when this equation is equal to 0, that is essentially your x-axis, and where it equals to your x-axis. So that's going to be x is equal to 1 over 2, or x is equal to 3. We have two spots. Okay? Now, draw the graph on the grid and state the x-intercepts and the y-intercept of the graph. Well, my y-intercept is always this constant right here. So let's draw this out. We're going to have the constant, so it's at 3. We also have 1/2, and then the other one's going to be at 3. So my graph is going to look something like this. Okay? And that is it. All right. Next question. It says, algebraically determine the zeros of the following functions. So we want to algebraically determine the zeros. So how am I going to do that? I'm going to make this equal to 0. 0 is equal to 3x bracket 4x subtract 9. Now, that means 3x could equal to 0 or 4x subtract 9. So we could have 3x equal to 0 or 4x subtract 9 is equal to 0. So let's solve for each one. Divide by 3, divide by 3, I get x is equal to 0. And the other one is going to be, I have to plus 9 as we solve for x, so I have 4x is equal to 9. Divide by 4, divide by 4, so I get x is equal to 9 over 4. So these are my two answers. Let's take a look at the next one here. I want to find the zeros. Okay, so I'm going to have to make this equal to 0. So 0 is equal to 5x squared plus 15x minus 20. Now, I'm going to have to factor this to do that. So what must I do? First, see if there's anything that can divide all that. I look at that, I know 5 can. So I take out a 5. I'm left with x squared plus 3x, and then we have minus 4. Now, I can use my trusted box method to solve for this. So let's move my box method. I have negative 4, and I have 3. I look at that, I'm going to have 4 and negative 1. So I have 5x minus 1 and x plus 4. So what are my values? Well, I look at this, I'm going to have x is equal to 1 and x is equal to 4. So my zeros are at 1 and 4. That is it. Okay? Let's take a look at number 6. Number 6 says, algebraically determine the x-intercepts of the graph of the function of the equation y is equal to 3x squared minus 11x plus 10. State the y-intercept of the graph of the function. Okay, so we want the y-intercept. Well, y-intercept's easy. It's always the constant. Y-intercept is equal to 10. Okay? Now, algebraically determine the x-intercepts. That's a little bit harder. But we have to algebraically determine them. That's the same thing as finding the 0. So, we have to make it equal to 0. It's equal to 3x squared minus 11x plus 10. Now, looking at this, see if I can simplify this. Can I divide everything by 3? No. Divide by 1, but that doesn't change it. So we're going to have to use the box method with this one here, and it's going to be the complicated one. So I will look over here, and I have 3 times 10 is 30. Okay, then on the bottom I'm going to have negative 11. Okay, so what gives us 30? Positive 30 and minus 11. So we need a positive and a negative. So I'm going to say, or both will have to be negative. So negative 6 and negative 5. All right, so now we have negative 6 over 3x, and we have negative 5 over 3x. This one here can be simplified to negative 2 over x. So when we factor it, I have negative 2, or x minus 2, and I will have 3x minus 5, or 3x subtract 5, and there it is factored. Now I could solve for x, make each equal to 0, and get my answer. So x minus 2 is equal to 0, and we have 3x subtract 5 is equal to 0, right? Because if this is 0, doesn't matter what this is, multiply this by that, doesn't matter what this is. If that's 0, this is, my answer is going to be 0. Same thing for this one. So I have x plus x is equal to positive 2, and here we add 5 to both sides, and then we're going to divide both sides by 3. So I'm going to get x is equal to 5 over 3. Okay? And those are my 2 answers. Hopefully you enjoyed this, hopefully you understood. See you tomorrow as we work on the assignments together.